Here's problem 25.5. What is the speed of a proton that has been accelerated from rest through a potential difference of 4 kilovolts? Well, if we had a proton, a positive charge, and if it were to pick up speed, it would have to go from a higher potential to a lower potential. In other words, its potential at point A would have to be higher than its potential at B. In other words, it would have to fall to a lower potential in order to gain kinetic energy, in order to get a velocity. So we can imagine that our potential at B is smaller than potential at A, so this potential difference, which is VB minus VA, is actually equal to a negative 4,000 volts, because our final potential is lower than our initial potential. And hence our change in potential energy, which is the charge times the change in potential, will be equal to the charge on a proton, 1.6 times 10 to the minus 19 coulombs, times a negative 4,000 volts. So that gives me a negative 6.4 times 10 to the minus 16 joules. That is our change in potential energy. Now we know that the change in kinetic energy plus the change in potential energy is equal to 0 for this field. So our change in kinetic energy will be equal to the negative change in potential energy. And so that will be equal to a positive 6.4 times 10 to the minus 16 joules. We know that 1/2 mass times our final velocity squared minus 1/2 mass times our initial velocity squared at A is equal to our change in kinetic energy. But our initial velocity at A is 0 because we started from rest. So we have 1/2 mass times our velocity at B squared equals the change in kinetic energy, or multiplying both sides by 2 and dividing by the mass taking the square root, our velocity at B is going to be 2 times the change in kinetic energy divided by the mass square root. That's going to be 2 times 6.4 times 10 to the minus 16 divided by the mass of the proton, which is 1.67 times 10 to the minus 27 kilograms, all that square root. So 6.4 times 10 minus 16 divided by 1.67 times 10 to the minus 27 times 2 square root, and I get 8.75 times 10 to the 5 meters per second. So that is the velocity at point B, our final velocity, and that's the velocity we have accelerate from rest as this positive charge falls through a potential of 4,000 volts.